Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu, and this lesson is brought to you by the Gauteng Department of Education in collaboration with Sabono Discovery Center. Today we're going to be looking at polynomials on this day, on the 14th of February, and happy Valentine's Day. The objective of today's lesson, at the end of this lesson, every candidate must be able to use the remainder theorem and the factor theorems. You must be able to factorize the third degree polynomials that we're going to talk to today using the remainder and the factor theorems. You must be able to, and the most important one, you have to be able to solve the third degree polynomials using the remainder and the factor theorem. So we're going to talk about the remainder and the factor theorems today. So you must be able to do that because that will assist you in terms of getting the x-intercepts of the graph, of the cubic graph when you do that in differential calculus. Right. What are the third degree polynomials? Now, if you look at this, a third degree polynomial has the form that, so it should have the form that, but we also need to check what must happen, which values of a, b, c, and d are real numbers, and what should happen to the value of a. So the ax cubed plus bx squared plus cx plus d. Now this is very important. The a and the b and the c and the d must be real numbers. In other words, we're only going to be talking to real numbers. I know you have done the complex numbers, already done with the complex numbers, but here we're talking about only the real numbers when talking to the third degree polynomial. Very, very, very important again, the a value must never be equal to 0. Now, if you check this, if I take the a value to be 0 there, then it means that that part here will be 0, and then I no longer have a third degree polynomial. So the a value can never be equal to 0. Any value b, c, and d can be 0, but the a value can never be 0 because that will never be a third degree polynomial. Now, these are just the examples of a third degree polynomial. You can see the highest power of the x there is 3, the highest power of x there is 3, the highest power of x is 3, and the highest power of x is 3. In this case, you can see that the d there is equals to 0. Then here you can see that our c is 0, our d is 0. So you see the a value can never be equals to 0. So here you can see the c there, it's equals to 0, and here you can see the b is 0, c is 0, d is 0. So which means that that is also a third degree polynomial because the x is to the power of 3, so it's cubic. So that's a third degree polynomial. The highest power of the x there should be 3. Okay. Right. Now let's look at how we divide the numbers. Now we know if I say 19 divided by 3. If I divide 19 by 3, what do? We can write this mathematically in 3 ways. So I can either write that 19 divided by 3, or I can write 19 divided by 3, or I can use that to divide by 3. Okay, so what do we get if we do this? We say 3 into 19 goes how many times? It goes 6 times. In other words, 6 times 3 will give us 18. But then we have a remainder that should be equals to 1. Sorry, that should be 1. Right. So we're saying the remainder when we divide the 19 by 3, that will be equals to 1. So if I take 3 and I multiply it by 6, I'll get 18. For me to get 19, I must add a 1. So that 1 is called a remainder because 3 cannot go into a 1. So how do I write this way? So we could use this, you can write this using one of the three conventions. We can say 19 over 3 is the same as 6 because it goes 6 times into that. But what is remaining is 1, so that is our remainder, and that will be 1 over 3. So if I take 6 plus 1 over 3, then I'll get 19 over 3. The division of algorithm, it's when I have a dividend, so meaning that my 19 will be my dividend, my divisor will be a 3. What is this? The quotient is how many times that goes into 3 goes into 19. Then I have a remainder which is our 1 and our divisor which is 3. So 19 divided by 3 will be a quotient plus the remainder divided by the divisor. So another way of thinking about this example is to say 19 will be the same as 6 times 3 plus 1. So I can write it like this. So in other words, how can I write that? It will be my quotient multiplied by my divisor and then plus the remainder. Can you see that? And that is how we're going to write it. We're going to say our dividend equals to the quotient multiplied by the divisor plus the remainder, and that will give us what we started with. Okay, and that's how we divide numbers. 18 divided by 3, 3 goes into 18 6 times, the remainder is 0. So okay, so we always have a remainder, but you know with the remainder of 0 we don't usually write it. We just say 18 divided by 3 will be 6, and we just write the number 6 without writing the remainder. Okay, now let's look at this question here. How do I divide polynomials? I was making an example with a simple number like 19 divided by 3, and we can be able to do that. But now, if we come to polynomials, how do we then divide polynomials? So we've got this polynomial. Is this a polynomial? Yes, we can see it's a polynomial. We've got this polynomial, and we want to divide it by x minus 2. So I can use what we call the long division method, which is tedious. I mean, nobody loves, a division by a long division method. But let's see what we get if we divide this and try this. But I know nobody loves this method. But let's do it. Let's see. Sometimes we get stuck in technical math. You still need to go back and say, but let me try it with the long method and see what will happen. Now x minus 2, 3x cubed minus 4x squared plus 5x minus 6. Now let's see. How am I going to now divide this? So remember, I'm dividing. What am I saying? Here, I'm going to have I have an x here, I have a 3x squared. So the first thing that I'm going to do, I'm going to say 3x squared, 3x cubed divided by this x. So I'm dividing it by that x. So I'm going to have x there, 2 left, that one cancels out. I'm left with 3x squared. So where do I put the 3x squared? On top there, 3x squared. Right, what should I do with the 3x squared? I must multiply it by that whole thing there. So I'm going to get 3x cubed minus 6x squared. Then what I'm going to do here, I'm going to subtract. Okay, so now remember, I multiply the 3x squared times x, gives us 3x cubed. 3x squared multiplied by negative 2, then it gives us a negative 6x squared. Now I subtract. The first part will always give us 0. Then we are going to have negative 4x squared, negative, negative. So it's a positive. So meaning that my answer there is going to be plus 2x squared. I drop down the rest, 5x minus 6. Because I'm just subtracting a 0 there. So now I then say the 2x squared I'm having there, I'm dividing it by x. In other words, I'm taking this one and dividing it by x. So I'm going to get plus 2x, right? Because therefore I'm going to divide this, I'm going to get 2x. I'm multiplying this 2x here by the rest of that. I'm going to have 2x squared. Then if I multiply that, I get minus 4x. Then I carry on, I drop that. So I'm subtracting again. I'm going to have a 0 there. Negative and negative will get a positive. Going to get 9x minus 6. I'm going to divide until I don't have an x. So what is the next one? I'm having a 9x. I'm dividing it by x. So I'm going to have a 9 there. So the plus 9, I'm going to put it there. Then I'm going to say 9 times x is 9x. Then from there I'm going to have negative 18. Then I subtract, and the answer there is going to be 12 minus a 6. So that, 18 minus a 6, that will give us a 12. And that 12, because x cannot go into 12, then we call that 12 a remainder. Okay, so in other words, what did I do? I calculated the remainder, determined the remainder when the polynomial is divided by x minus 2. But here I was using the long division, which everybody hates, but still we need to practice it and do it. Okay, so the next question will still be on that, using the long division method to calculate the quotient and the remainder when. So we are having a polynomial here. So here is our polynomial. Here now we are requested to calculate the quotient and the remainder. So in other words, I must write down. In the other one, I was just dividing. In this one, then I still have to write the quotient and the remainder. So you can see here I have x cubed, x squared. The c, it's not there, so it's a 0, and the d is there. So which means I'm going to have, I think the easy way to write it will be to do this and write x cubed plus 3x squared. I'll just say plus 0x minus 5. Then I have a b, c, d. Okay, so I'm having an x plus 3 here. So I'll do the same, the division, same division. X cubed divided by x will give us an x squared, right? Then from there we'll have x squared multiplied by x will give us x cubed. X squared times 3x will give us plus 3x squared. Subtract this, subtracting that. So I'll have x cubed minus x cubed, it's 0 here. 3x squared minus 3x squared is also 0 here. So I'm going to write this 0 there. Then we move on the 0, x, and the minus 5. Okay. Now we're going to say, in this case, I'm now going to say x into 0, it will be 0. Okay. So x into 0, it will be 0. So what am I going to get here? So I'm going to get a 0. So now I'm now going to have a 0x minus 5. So there I'm going to have a 0x. Then from there I'm going to have, obviously the minus 3 will be there. So we'll have a minus 3 in there, right? Then from there we're going to have a plus 3 there, sorry. Then we're going to, because we'll have moved the plus 3 down, and then we'll have a minus there, and the answer there will be negative 8, which is going to be our remainder, and there we're only going to have an x plus 0x plus 0x. Okay, so now I'm now going to have the x squared plus the 3x squared minus 5 will be equals to, so it will be equals to the x squared multiply by x plus 3. Remember, we are going to multiply the quotient, which is x squared. We're multiplying by the divisor, and then from there we're going to add the remainder. So if I multiply out these, I'm now going to get x squared times x, which is going to be x cubed. Sorry, this is x cubed. X squared times 3 will give us 3x squared. We have a 3, which is going to be 3x. Sorry, there's some mistake that was done there. Okay, can I just clean this for a minute, please? Okay. Now, we have a 0x there plus 0x, and then we have a negative 5. Sorry about that. Now we have, this will give us a 0 there. This will give us a 0. And if I drop this, I still get a 0 there. Okay, and then from there we drop that, and then we have a negative 5. So if I drop that, I still get a 0x. And then from there, the same thing, then x doesn't go into 0x. So what is left there will be negative 5, and then negative 5 will be the remainder. So if I want to write it properly, then I'll have x cubed plus 3x squared. Obviously, it's minus 5. I'm going to omit that 0. Then that will be equals to, now what is our quotient? Our quotient is going to be x squared. Then we have our divisor, which is going to be x plus 3. Then we've got our remainder, which is negative 5. So if I multiply this out, I'll get x cubed. Then I'll get plus 3x squared. And then I'll get a negative 5, which is our remainder there. So meaning that if I need to write down this, our quotient is going to be x squared. Our remainder is going to be negative 5. We already know what our divisor is because that was given. The one that we did not know is our quotient and also our remainder. So our quotient will be x squared. Our remainder will be negative 5. So that's how we can do it. So it is very important that we also write this down so that then we bring that down. We also bring that down. And then we can see that one was 0, and then that one was 0, and then this one we bring it down. X can go into a 0, x, and then from there we'll have a negative 5 in there. Alright, I hope you understand the long division method. It is very long. It's called that long division method, so we really need to also practice it. Those who like the other methods, they will also do other methods, and then we'll check which method will help you understand this. Okay. Now the function notation. The function notation, we've done function notation in the lower grades. I mean, we have substituted with the values, and when you're doing the functions, we substituted with the values. Let's look at the cubic ones now. Consider this function. See, there, the notation is very important. The f is the name of the function. In other words, you find that some functions will be the g of x, you know, so the letter g is the name of the function. So I'll say this function here is called the g function. This function here is called an h function. So the f represents the function. The x here represented the value at which to evaluate the function. In other words, it's our input. So it gives us that. So that whole thing there, it is the rule. You know, in grade 9 and grade 10, you've done the rules. So that is the rule that says how to calculate the function's output for a given input. So my input is the x. So whatever is given as x, I must substitute it into the value of x in there to get the output. So the function notation is very important. If I'm given f of x, f of 3, which means I must substitute the value of x by 3. Okay, right. Let's look at the activity there in the function notation. Look at this. I'm given g at x. It's 8x cubed plus 20x squared plus 14x plus 3. Now, the first question says calculate g of 1. What does that mean? It means that wherever I see an x, I'm going to substitute the x by 1. So which means in the first one, I'm going to say 8 into 1, 1 must be cubed, plus 20 into 1, 1 must be squared, plus 14 into 1, plus 3. So I can use a calculator, which is an easy thing to do. But if you try to use a calculator in single terms, that's where sometimes we make mistake, and sometimes we just calculate it incorrectly. I've seen learners doing this, and please don't do that, saying 8 to the power of 3. Here the 8 is not to the power of 3. Which one is to the power of 3? It's 1. So 1, it is to the power of 3. Here the 1 is squared. Here the 1 is multiplied by 14. So I cannot multiply 8 times 1. Remember, we use what we call BEDMAS. I know you have done BODMAS, but we use what we call BEDMAS. And the BEDMAS stands for is the brackets, and then we are going to do the exponent first. So in other words, here the rest you know. Okay, here we start by saying 1 to the power of 3. After we have done that, we multiply that by 8. So we don't say 8 times 1, so it's exponents first before multiplication. Very important that you understand that. 1 to the power of 3, it's 1. 1 times 8, it's 8. So my answer to this is going to be, if I use my calculator correctly, I think the answer will be 45. So it will be 8 plus 20, 28, 28 plus 17, will give us 45. Okay, same applies to this one. We will go and say 8 into negative 2 cubed plus 20 into negative 2 squared plus 14 into negative 2 plus 3. Use a calculator. Then the calculator, use the calculator, we say 8 open bracket negative 2 cubed plus 20 open bracket negative 2 squared plus 14 open bracket negative 2 plus 13. So if you do all this, then the answer there becomes negative 9. Okay, those are easy things to do. Okay, right. G of 0, this one I think everybody can get. You don't have to actually work it out, but let's work it out. We're saying 8 into 0 cubed plus 20 into 0 squared plus 14 into 0 plus 3. So obviously, if I multiply by 0, I'm going to get a 0. I'm going to get a 0 there. Multiply by 0, I get a 0. The only answer, the number that is left is 3. Okay, and that you're going to do when you do your graphs. Please look at this, because G of 0 is nothing else but your y-intercept. That's where the graph is going to cut the y-axis, because the value of the x value is 0 there. Okay, right, the last one, 8 into 3 over 2 cubed plus 20 into 3 over 2 squared plus 14 into 3 over 2 plus 3 is equals to. So if you work that one out, use a calculator also. Please, when you use a calculator, as I say, do it once. Don't do the first part and do this one and do that one, and from there you add a 3. And sometimes we make mistakes there, and then especially when we have negatives. So you just do it as it is, put in a calculator, and the calculator will give you an answer. I think the answer that I got there was 96. Please check if I am correct there. Right. Okay, now the remainder theorem. Remember what we were doing there? We were dividing with the long method, and we got the remainder. I think the first one that we got was the remainder was 12. The next one was negative 5. So we got the remainder there, and now we did the function notation. So here, after doing the function notation, we're coming to the remainder theorem. And please, whatever we have learned previously, make sure that you know now how to substitute in a function notation. Let's look at this one. It says use the remainder theorem to calculate the remainder when this is divided by x minus 1. Now I'm going to show you what you need to do here. Easy things to do. Remember, we used the long division method, and then we divided, and from there we got the remainder. I'm going to show you the quicker method of getting the remainder when just getting the remainder. This is what we want. We only want to calculate the remainder. So how do we calculate the remainder? Now, the formula for the remainder says if I take f of, first equate this to 0, get the value of x. The value of x is 1. So which means I'm going to substitute the value of x by 1 here. What is left will be my remainder. So I'm going to say f of f of 1 will be equals to. So remember, I'm going to substitute the 1 plus 5 into 1 squared plus 7 into 1 minus 10. So I'm going to get, so obviously I'm going to get negative 2. Please don't do what I'm doing. Plus 7 minus 10, because you can just put this in a calculator and then get the answers. So if I check this, 5 plus 7 is 12, minus 2 minus 10 is negative 12, 12 minus 12 is 0. So my remainder here is 0. So I'm able to get a remainder if I'm not given. I'm not asked to solve the equation. So here I'm not asked to get the quotient. For me to get the quotient, I must use the long division method. So I must get the long division method to do that for now. But when you go on with the slides, then you'll see that I can use, actually don't need a long division method, I can use other methods to do that. Okay, so now the next one also need us to get the remainder. So calculate the remainder using the remainder theorem. Remember, the remainder theorem tells us that f of that part of the divisor will be equals to the remainder. Okay, so in this case it's telling us that if I take my divisor, equate it to 0, solve for x, the f of that number will be our remainder. That's all that we're doing. If I'm requested to calculate the dividend, as I said, long division method for now. But now here it says, now I need to look for f of a half, which means the value of x must be substituted by a half. Value of f must be substituted by a half. The value of f must be substituted by a half plus 1. So which means now going to, so this is 2 into 1 over 8. Please don't do this. Use a calculator directly from there. We have 1 over 4 minus the 2 and the 2 cancels out. I'm going to have a 1. Then I'm going to have a plus 1. Right? So now I'm going to have 2 multiplied by 1 over 8 will give us 1 over 4 minus 1 over 4. 1 minus 1 plus 1 is 0. And 1 over 4 minus 1 over 4 is 0. So which means that our remainder will be equals to 0. So the remainder is 0 there. So we're going to talk about if the remainder is 0, what does that mean? We're going to be looking at that also. Here's an interesting question. An interesting question here. Now in this case, we are calculating something here. We need to calculate the value of a here. Must be a comma there. Given that is divided by x minus 1 and the remainder is now given. So the remainder is given, we need to calculate that value of a here. Tricky question, but I don't think it is very difficult. So x minus 1 is the divisor. What do we do with the divisor? We say x minus 1 equals to 0. Then our x value will be equals to 1. So what do we do with the 1? We are going to name this polynomial here. I can name it h of x, doesn't matter. H of x is 4x cubed plus ax squared minus 2x plus 1. So I'm going to substitute the value of x by 1. So I'll have h of 1. It's 4 into 1 cubed plus a into 1 squared minus 2 into 1 plus 1. So remember, I'm told that the remainder is 1. Remember I told you that the function of that gives us the remainder. Now I'm given that the remainder is 1, it's 10. So the remainder is 10, which gives me 4 plus a minus 2 plus 1. So I want to solve for a here. So a will be equals to 10 minus 4, it's 6, 6 plus 2, it's 8, 8 minus 1, it's 7. So the value of that will be 7. So a value will be 7. So if a is 7 here, what does this mean? It means that the remainder that we're going to get there is going to be 10. Okay. So the remainder theorem, it is not very challenging. It is very straightforward. We're just substituting, getting the value of the remainder by substituting. This was just a bit of a challenging question to do. We're going now to take 2 minutes break before we continue with our activities. Okay, now let's move on. Now, the next question here says calculate the value of A given that the remainder is 0 in this case. As I said, we are going to talk about when the remainder is 0, what happens when the remainder is 0. Now we say calculate the value of A an element of real numbers, given that will be equals to 0. So what do we do here first? Same thing. We are going to say 2x minus 1 equals to 0, which will give us x is equals to a half. What do we do with a half? I'm going to name this one now. I'm now going to call it p of x is equals to 2x cubed. We need to name our functions ax plus 1. Then we substitute the x by a half, which will be 2 into 1 over 2 cubed minus into 1 over 2 squared plus a into 1 over 2 plus 1. Okay, so now if I add all this, remember this is our remainder, so the remainder there is going to be a 0. So I can work this out because that one will be 1 over 4, that one will be 1 over 4, this one will be half a, and then from there we have a plus 1. So this will give us a 0, this 2 will give us a 0, a quarter plus minus a quarter is a 0. So I'm going to actually have half a equals to negative 1. Then I can multiply out by 2, a will be negative 2. So the answer to this will be negative 2. What does this mean? It means that my a, if it's negative 2, then the remainder that I'm going to get will be a 0. Okay. Please take note of what we're doing in terms of the remainder of 0, because in the next activity we are going to be looking at what happens when the a is when we get a 0 as the remainder. Okay. Now let's look at this. the factor theorem. Now, if I take an example like this one and say 12 divided by 4, the answer that I'm going to get will be a 3 with a remainder of 0. So check this. If the remainder is 0, it means that this 3 here, the answer that I've got, which is 3, which is the quotient, it's from 12 divided by 4, which means that now the 4 is a factor of 12. So it means that it goes 3 times and the remainder becomes a 0. So we call it a factor. And that is called a factor theorem. And you know, when I talk factors, grade 8 and 9, when I say, what are the factors of 12? And then you give me the factors of 12, which are 1, 3, 1, 2, 3, 4, 6, and 12. So those are the factors of 12. So 4 is one of them, and it gives us the 3. So let's look what does the theorem say. So you don't have to memorize this theorem. You're not going to be asked this theorem in an exam. We say if this polynomial which is given here is divided by this thing there, you see this is the divisor, then k over a minus k over a. How did you get this? It's because we said a of x plus k is equals to 0. Then we solved for x. So ax equals to negative k, and then x will be equals to negative k over a. So this thing here, it gives us 0. If it gives us a 0 like it has done there, then this thing here is a factor of a polynomial. Simple and straightforward. So meaning that if I've got a divisor, and that divisor it divides the dividend, which is that polynomial. If I get a remainder of 0, it means that that divisor is a factor. That is the factor theorem. Now, so this activity, it says, show that x minus 1, what is x minus 1? It is the divisor. Is a factor. Show that it's a factor without solving the equation. You see, I don't need to solve the equation if they say do that. So the divisor that I'm going to be getting here, it's x that I have here, it's x minus 1 is the divisor. So I'm going to equate the divisor to 0, and I'm going to get x is equals to 1. So now I must show that this thing here, if I put it here, the answer that I'm going to get will be 0. So I'm going to say f of 1 is equals to 1 cubed, put brackets please, plus 1 squared minus 1 minus 1. So if I get 1 plus 1 minus 1 minus 1, my answer gives me 0. You see, so if it gives me 0, what do I say? I'll say therefore x minus 1 is a factor of f. Okay, because the answer that I got 0. Say for instance I got a 5, I'll then say x minus 1 is not a factor. But here they say show that this is a factor. So in other words, they're forcing you to get a 1. Now we are not going to mark it correct if you just say f of 1 is 0. You must show all steps showing that you have substituted, you added to get the value of 1 of the f of 1 to be equals to 0. Okay. In the next one it says hence factorize the polynomial this one. See now, we now need to factorize it. But now I already know that that other factor is it's x minus 1. So now how am I going to factorize it? Now I'm going to show you a method of factorizing by inspection. Quick one. If I've got f of x, it's equals to this x cubed plus x squared minus x minus 1. Then I know that x minus 1 is one of my factors, but let me try this now. I'm not going to use the word hence now. I'm just going to try this, show you the easy way to do it. If I take these 2 and this 2 and I group them, I will have factorize this one, this 2. The factors of that will be x squared, because that's the highest common factor, and then I'm left with x plus 1. And the x plus 1 is the one that we got previously. Sorry, it's not the one that we got previously. We still need another one. So we'll have minus, if I take this one and factorize it, sorry, with a sign, sorry, minus, there's the sign, I close the bracket, I'll get x plus 1. If I multiply this out, I still get that one, because minus 1 times x is minus x, negative times positive is negative, so I still get it. Then I can see I've got a common factor, which is x plus 1. Then what is left here will be x squared minus 1. There's the ghost 1 here. Now I can then factorize. In this one you must learn how to factorize. Then I'll get x minus 1 and x plus 1, which can be written as, I can see these two are the same, can be written as x plus 1 all squared and then x minus 1. So the x minus 1 is the one that we started with. If I needed to do this using the word hence, it means now that I need to use the long division method, because there's no any other method that I know for now. I can use the long division method because I've got x minus 1 as one of my factors. Then I'll have x cubed plus x squared minus x minus 1. So I can use the long division method. And I hope and trust everybody now understand how to use the long division method. Then if you do the long division method, you are going to arrive at that by using the long division method. So I just use the short one because I could see that this one out, I can use the common factor. It is not always the case that you're going to use the common factor in this polynomial. So with this one, I'm lucky, got a common factors, and then I can see that these two I can have a common factor. Please, not all polynomials are there that you can use common factors. Please, you can either try, if you try and then you see it doesn't give you a common factor, and then you can use other methods. Okay. Right, factorizing a cubic, but before we factorize a cubic, let's look at this question, because that question is also key in terms of us understanding how to factorize a cubic. We first need to look at how to get f of minus 1. We're not going to waste time on that. We have done this activity. If I take minus 1, then I substitute into that a polynomial. The answer that I got there was minus 20. You can also try this. Substituting by 0, I'm going to get that 0. It's a nice one because it gives me a number without an x. So that will give us negative 14. I substitute by 1, then I get 0. Now the question is, which one is a factor of f and why? So if I look at these three here, I can say that the only one that gives us a 0 is f of 1. So the f of 1 is a factor. So what are we going to write here as a factor? Remember, if f of 1 is equals to 0, I want to write it as a factor. I'll write it as x minus 1. The reason for this is that when I equate it to 0 and solve for x, the answer that I get will be 1 here. Right. Why? It is because the f of 1 gives us a 0. If it gives us a 0, it means that it's a vector. Okay. Right. Now the next question will say factorize this one. What we're now doing is we need to factorize this whole thing. If I try common factors, then I'll have x squared here and then x plus 9, and there's no factor in there, and then now I'm stuck. So common factor will not work. The best thing to do there is to maybe try and do a long division method. I can use the long division method to do that. Now with the long division method, I still have to, I don't have a divisor. That's the first thing that I'm looking at. I don't have a divisor, so I must make a plan. My plan in this case is to look at how I'm going to get my divisor. So how am I going to get my divisor? I'm going to use try values. So I'm going to try some values. So I'm going to name this. I'm going to name it. Now, how am I going to name this? So I'm going to say this is going to be maybe my f at x. Okay. So I'm going to try some values. So I'm going to try f of 1. Sometimes when you try, then it's easier. Then you get it quickly and then it's fine. If you can try 1, minus 1, 2, minus 2, 3, minus 3. Most of the case you'll get it from minus 3 to 3. You'll get a factor. So let's try 1, for instance. I'll have a 1 here, plus a 9, plus a 23, plus a 15, and this answer will never give me a 0. I'm stuck. Then let me try f of negative 1. I'll have a negative 1. I'll have a plus 9. I'll have a negative 23. I'll have a positive 15. And using my calculator there, I'll have 9 plus 15 is 24, minus 23, minus 1 is negative 24. I'll get a 0. Yay, I'm lucky. Okay, now if it's minus 1, I know that my factor will be x plus 1. So this one will be my factor, is a factor of f of x. Right. So if it's a factor, how am I going to get the other values? How am I going to get the other values? Remember, I'm factorizing it. So I only have one factor, so I need the other factors. How am I going to get the other factors? Now I'm going to show you this one, which by inspection. Why am I saying it's by inspection? I'm just going to look at the whole thing there. Now you must listen carefully. I'm going to write down the value. I'm going to write down one factor. So I'm going to say x plus 1 is one factor. Remember, it's f at x. Then I'm going to write down a bracket, bigger bracket. What should I multiply x with so that I can get x cubed? So I'm going to write x squared here. So that's my first one. What should we multiply by positive 1 to get a positive 15? So that will be a positive 15. So I'm going to write positive 15 here. Plus 15. Now I'm left with the middle term. How am I going to get the middle term? Please pay attention now. What I'm going to do is I'm going to multiply the 1 by this x squared. I'm only looking at this now. Don't worry about this one. You'll get it. I'm looking at the 9x squared. What should we multiply by? What should be added? I've got 1 times this. What should I get? What am I going to get? I'm just going to write it here. I'm going to get 1x squared positive. How many x squares do I need to go to 9? That's what you ask yourself. So 1x squared plus something x squared will give me 9x squared positive, right? So I'm going to say x squared plus this thing here, x squared gives me a 9. So what will that be for me to get a 9? So it will be an 8 here. So that will give us 9x squared. Okay, so or I can divide throughout by x squares, and then you can then get the value of the box. So here meaning that I need how many? 8x squared. So I just write 8x because that should be multiplied by that. So to give me x squared. So I multiply this 2 here, I get 8x squared. I multiply this one here, I get 1x squared, and that will give me 9x squared. The 23 will come out. If you multiply this 2, you get 23. So then I can then check x plus 1 into, I can factorize this. I think this can be factorized. I think 5 and 3 can do here. 5 and 3. So my expression now is factorized. So I can factorize it like that. Okay. This is by inspection, by just adding numbers and doing that, and then we are able to can get to the answer. Now, the long division, we have already done that. I want to show you that the previous question that I've done, we can get answer by using the long division also. So here, I'm going to write down the factors that we got. I think it was x plus 1, x plus 5, x plus 3, x. Right. Now let's look at the long division. Let's look at the long division. With the long division, I'm now going to divide this. I'm going to take the factor of x plus 1. So I'll have x cubed plus 9x squared plus 23x plus 15. So now here we are solving for x now, remember. So now I'll say x cubed divided by x will give us x squared. We go here, we got x cubed plus x squared. Then we subtract. 9x squared minus x squared will give us 8x squared. Bring down the 23x plus the 15. Right. Now 8x into 8x squared will go 8x. Now multiply out, you get 8x squared plus 8x. Subtract 23 minus 8, it's going to be 15x. You bring back down the 15, then plus there you get the plus 15, then you get 15x plus 15, and then you get a 0 there, which is our remainder. Remember, x plus 1 is a factor, which means now that my f of x will be this one factorized will give us x plus 3 and x plus 5. So you see now we have this, but we are solving, it must be equals to 0. So we get x plus 1, x plus 5, x plus 3, and then the values of x are going to be -1 or -5 or -3. That's our zeros of the graph if you are doing a graph. So when you do the graph, you're going to come back here and do as we have done here. Okay, going to practice that and do it as we have done here. Okay, now, so the long division method actually it is tedious. You can be able to do that. I've shown you how to do it using the inspection. So we're also going to look at how we're going to do that in using the other methods. Okay, solving by inspection again. 2 ways to do that. I'm going to show you 2 ways of doing this by inspection. Solve for x. X is an element of real numbers. So how are we going to do that? First, look at the grouping. So sometimes you find that it can be grouped, and grouping is the easier one. We have done it in grade 9. Let's look at what we can do here. Can the grouping work? I think so. I think the grouping can also work here. I can go with the grouping method. So in other words, with the grouping, I can take x squared, I group these ones. So I'm going to say x squared into x plus 2. Am I right? X squared times x is x squared, x cubed. X squared times 2, it's 2x squared. Super. Then from there, I can take out a common factor, but now when I take out a common factor, remember I'm taking it with a sign also. So I can take out a common factor and then I'll have x plus 2. Remember, this is equals to 0. So I can see x plus 2 is a common factor, and what is left here, x plus 2 is a common factor. What is left here is x squared minus goes to 1 here, right? Then I'll have this is equals to 0. I have difference of two squares. Please know that x minus 1, x plus 1 equals to 0. My values of x, because I'm solving for x, it's negative 2 or 1 or negative 1. So I'll have that as those three as my answers. Those are called zeros of the graph. Okay. Now with inspection, solving by inspection, I mean this it's grouping. Solving by inspection now we'll have, I can take 1 as my, remember you must try values. So let me say I've tried 1. So x minus 1 will be a factor, 1 factor. Now I need the other factors. I'll check this. That is the one that I've done previously by inspection. So I'll have, please pay attention now. X, to get x cubed, we need x squared. To get minus 2 from minus 1, we need plus 1. Right, we need plus 1. Because if I multiply, sorry, plus 2. Because if I multiply negative 1 times plus 2 will give me a negative 2. So with this 2, I'm done. Now I look at this one, the plus 2x squared. So what do? I look at this 2. I'll say negative 1 x squared plus something squared will give me a plus 2x squared. Okay. So I can divide throughout by x squared, doesn't matter. I need a box. I need my box. So then I'll have minus 1 plus a box equals to 2, because the x squares will have cancelled out. Now I'll have my box. Number that I need will be 2. Transpose this one that side. It's 2 plus 1, it's 3. So my box is a positive 3. And I just put an x. So this is by inspection. Okay. So now I'll have x minus 1. This can be factorized, I think. X and x, 2 and 1, plus and plus equals to 0. My x value will be 1. There's the 1. My x value will be negative 2. There's negative 2. My x value will be negative 1. There's negative 1. So I'm done. So I can either use by inspection, or I can either use grouping. As I said, it will only work with some, not with all of them. So we must first check how, if it can work. If grouping can work, easy, good for you. It's easy one. If it doesn't work, you can use an inspection. Then we've got two other methods. You can use the long division method, also works. Then we have the last method that we're going to be doing to show you how we can do it. So we're going to take some few minutes or so. We're going to take 2 minutes break. Then we continue. Okay, just to quickly go back to the inspection one. So with the inspection, make sure that you understand the ones that you need to multiply. So we're going to look at the ones that we need to multiply. So we need only to multiply the 1 minus x, sorry. So we just need to multiply the 1 minus x and then 1 minus x squared, and we also need to multiply that one. So those two, we must always look at the squared. So if I look at the squared, it's a plus x squared, and if it's a plus x squared, then the answer for me will be 3. So here you can put in an alphabet. I can put A here, I can put any alphabet there, then from there, but I prefer the box because that's what I need here. I just need the number, remember. So those are the ones that we need to multiply. So that part here is the one that we don't know, so that's one we are going to put a box in there. Then you can multiply out, get the value of that box there, and then the answer will be correct. Easy, straightforward, and then you can be able to do that. I hope and trust. Now, there's another one where you need to use a calculator. Know you love your calculators. So now the display on the I've just put the display on the calculator. If you've got a Casio calculator, you can just do it with me. Now solve for x where x is an element of all real numbers. First of all, what you do on a calculator, you make sure that it is on a DEG mode. Right? Then from there, the first button that you press will be the mode setup. So you go to mode setup, click on the mode setup, then you click on the table number 3. So you just click on the 3. So you go from mode setup, then the next thing you press on the 3. Then from there, your calculator is now going to give you a f at x. After it gives you f at x, then you put in that your x on the calculator, it's on the close button. So you see the x, but first you must click on the alpha mode. So if I click on the alpha mode, it gives me all the red ones. You see all the red ones I used when that one is activated. So I activate the alpha mode, I press the X, and I've got an X cubed here. So I can, don't just press on the X cubed, please. You must first press the alpha mode and then the X, the close bracket, it gives you an X, and then you can put the X cubed there. Then it will be X to the power of X exponent 3. So you say plus, and then from there you go and put a 4, and then you go to the alpha mode, you go to the close bracket for the x, you put a square, there's a square in there. Then now we go to 11, so you just the negative 11, you put an x there from the alpha mode, then from there you just say minus 30. And the display that is going to come up on your calculator will be that. So you insert the expression. So your expression will be x cubed plus 4x squared minus 11x minus 30. And then from there you press equal sign. If you press equal sign, then some of the calculators will give you g of x. So in other words, they're asking you if you have got another equation that you want to work with. Then because you only have one equation that you are working with, you press equals to again. Okay. Now you have that on your display. The next slide, it's going to tell you where do you want to start with your table. Now I want to start on my table, but you remember on a table, so it uses the number line actually. So now I want to start at negative 5. I think negative 5 will be fine for now. So you can start at negative 10, but now you're going to have a long table. Okay, so now I know some of the factors. I can see these factors here, 30 and 11 and 4. I mean, those numbers will be around there. Even 6, I can also use 6. So I'm going to click, I want to start at -5. See the number line here. Okay, where do you want to end? The next one will say, where do you want to end with this? Now I'm going to say, I'm going to end at 5. I've got a -5 and 5, so that's my inputs. Okay, so those are the inputs. In other words, those are the values of x that are going to be substituted there. So the calculator is going to substitute for you -5, -4, -3. It's going to make your life very, very, very easy because it's substituting for you. Remember, you're supposed to substitute for yourself and say f of 1, then you substitute f of 2, f of 3, f of -1, f of -2, f of 3, f of -3. You have to substitute it on your own. But the calculator now is making it easy for you to substitute, right? So now, so the next slide will say step. So in other words, how many steps do I want to do? Remember, I want this is my number line, so I want this to be 1, 2, 3, 4, 5. I don't want decimals, I don't want decimals. I just want these numbers here. So my step is from here to there. It's one step, one step, one step, like that. See, when you're doing the trig graphs, it will ask you step, and then you say maybe that thing is going to be, my intervals are going to be 30, 60, and all that. But with this, we use step 1. You click 1 in there. Then every time you click equals to move to the next one. And then from there, what the calculator will do, it's this. It will give you a table. In this table, you can see this table. In this table, you scroll down by using this one, up and down by using that button here. So if I scroll up and down, can you see that when I scroll there, I've got a -2 there. So I've got a -2. So it says my x is -2. At -2, it is giving me a 0. So in other words, it's giving me my f of x. If my graph is named f of x, it's 0. So at f of 2, sorry, not f of 2, -2, it's saying at f of -2, my graph is 0, which means that it's a vector. That is a vector. How do I write it properly? I'll write x plus 2 is equals to 0, and x plus 2 is a vector. So it's a vector. Why? Because it gives us 0. The rest are not vectors because they're not giving us 0. So that is one of the factors. So here I know that one will be x plus 2 is one factor. Now I scroll up, down, and then I see, oh no, at -5 it's also giving me 0. So which means that x plus 5 is one of the factors. Alright. Again, I scroll up and I see, oh, at 3 it's giving me a 0. Oh, which means that x minus 3 is another factor. And I've got 3 factors. Obviously, this times that will give me x cubed. Already the x cubed is there. I don't need another factor because if I get another factor, it gives me x to the power 4. Okay. Then if I multiply 2 times 5, it's 10. 10 times -3, it's -30. So that one I also have. So I'm lucky in this one because I get all the factors on my calculator. So what is left for me here? It's nothing else but to write down the values of x. So sometimes the calculator will then make life easy because it will give me all the factors. So sometimes it might give me 2 factors and I need the third one, which is going to be easy. Sometimes it can give me one factor, then I need the other one by inspection or by long division method. Okay, right. So the calculator is a very handy tool. You must make sure that you have your calculators with you at all times when you're in class, because this thing called calculator makes life very easy for us. Okay, once you know how to use it, very, very, very easy. And I know you've already used it in complex numbers. It was easy to use a calculator in there. So please make sure that you know how to use the calculator. Right. Now, here's another method that I'm going to, this is my last method to work out this. It's called a synthetic method. I know your teachers love the synthetic method. They see it as a very easy method, and it's absolutely an easy method to use. I'm using the very same equation, so that then you see that the answers that we get are still going to be the same. So the synthetic method is also, as I said, one of the methods that we can use. But for us to get the synthetic method first, we need to get one factor. So remember, to get the factors, you must try x equals to 1, or x equals to -1, x equals to 2, x equals to -2. Then from there we can try this. But to save time, I've already worked that one out. The 1 does not work. The -1 does not work. The 2 doesn't work. The -2 works for me. So which means that the x minus 2 will be one of the factors. You can go on and make the 3, -3, 4, and -4, 5, and -5 if you've got time. But you remember, in exam, you don't have the luxury of it. Okay, so here what are we going to do? We're going to say we have 2, -2. I'm going to use -2. So I'm just going to draw this. I'm going to use -2. So in this case, I don't write the x. Now I'm going to write down the coefficients of this. Right? I'm not going to write down the x. So I'm just writing the coefficient with its sign. So the coefficient of x cubed is 1. The coefficient of 4x squared is 4, +4. This one is -11. That other one is -30. Right. Now I'm going to draw a line here. Okay. Those are the coefficients, and I've got -2 there. So first of all, what I'm going to do is the first value, the first coefficient, I write it as it is. Okay, I don't do anything with it. Write it as it is. Then I'm going to say -2 times 1 will give us a -2, but I put it under that. So I'm going to put it under that. Okay, right. Now, in this case, I don't subtract, but I add. Okay, I add. So also 4 plus -2 will give us a +2. Will give us a +2. So I'll have a +2, no problem with that. Now the next one, I'm then going to say, now if I multiply the 2 by the -2, I'm going to get a -4. Remember, I'm adding, so I'm going to get -11 plus -4 will give us a -15, right? And a -15 multiplied by -2 will give me a +13. If I add a -30 plus a 30, I'll get a 0, and this is our remainder, which means that is a factor, so I'm fine with it. What do these 3 mean to me? It means I've got x -2 as our factor, so which means that I'm going to write it as x plus 2. Remember, if it's -2, I write it as x plus 2. Then I'll have this one, I just put my x squared, my x, and no x. So these are the coefficients of the quadratic equation. So I'll have x squared plus 2x minus 15 equals to 0. Then I can factorize this. I'll have x, I'll have a 5, and a 3. So 5 will be positive, 3 will be negative, equals to 0. I write down my vectors, -2, my values of x, -2, or -5, or 3. Remember these 3 values? We also got them in the previous one. So our values will be -2, -5, and 3, and are the same values as we got in the previous one, which is -2, -5, any three. Okay, so the synthetic method, I know your teachers love it also. Please understand it. It works easier all the other methods than all the other methods. But some will say, now I don't want, I want the long division, I'm comfortable with that. Please suit yourself from that, but practice all of them so that when you get stuck with one, you know how to do the other one. When you're stuck with the other one, some of the question you realize that, oh yeah, I don't understand. There's no C, there's no D, there's no B, there's no C. Remember, A must always be there for third degree. So there's no B, there's no C, there's no D. How am I going to do this and how am I going to put the values? Please make sure that you really understand what you are doing in there. But the last question is also this one on the synthetic method. Now this is the one that I was talking about. That see, in this one we have A is there, B is there, and then C it's not there, D is there. So we need to see how we can be able to do that. So first of all, we're going to try, you know, x 1, x minus 1, x2 minus 2, 3 minus 3. Then to save time, I worked that one out, and then 2 was a factor. So 2 was a factor, and then we got 1 here, got negative 7 there, we've got a plus 0 there, we have a plus 20 there. Can you see what I've done now? Done the same way as I've done with the long division method, but in this case, I now put a 0. Why am I putting a 0? Because our C value there, it's 0x. Okay, so that's why I put a 0 in there. Okay, we do the same thing there, draw a line there, bring over the 1 will always remain there. And then I'm going to have a 2 here, 2 times 1 is a 2. Then remember I'm adding, so minus 7 plus that will give me a negative 5. Okay, then a negative 5 multiplied by 2 will give me a negative 10. Okay, so can you see now I've got a negative 10 in there because I've multiplied this one there. So if I did not put this 0 there, so I'll have messed up, because then the 20 is somewhere here, and then I'm not able to can figure out how I'm going to put the minus 10. So there I'm going to say 2 times negative 5 will give me a negative 10. Okay, sorry, 0 by plus negative 10 is minus 10. Negative 10 times 2 will give us a negative 20. If we add 20 minus 20, that will give me 0, which is my remainder. I'm covered with that. So now it means I'm going to have, remember it's a plus, so it will be a negative. These ones are the coefficient of my quadratic. I'll have x squared minus 5x minus a 10. That gives me a 0. And then from there I can get the values of x. I'll say x will be equals to 2. Right? So I'll let x equals to 2, or factors of this one, factors of 10 that can give us 5. No factors there. So meaning that I must go for quadratic formula. So I'll have minus 5 will be a 5, plus minus the square root of negative 5 squared, negative 4 minus 1 times negative 10, all divided by 2 times 1. Then I can, from here, use a calculator to get to the final answer. So the final answer, use my calculator, I think that will be 25 plus 40. So that will be 65 plus 5, square root of 65 plus 5. And then from there the answer will be 6,53. Or the other answer will be negative 1,53. These are the 3 answers that I'm having, and I can now be able to can plot my graph. The x values of the graph. So remember this, we are preparing you to understand this so that when you do the cubic functions, you are able to can get the x, the zeros of the graph, and this is the method that we're going to be using. And when they're doing the graphs, let us make sure that we understand how to get the zeros of the graph. This is the method. You've got three ways of doing it. You've got inspection, you've got calculator, you've got a synthetic method, you've got the long division. You actually have four methods to do that. But with the calculator, remember, you might get one or two. Lucky, you'll get three of them. But if you get two of them, then you can be able to can get the third one. If you've got one of them, meaning that you have to use the long division or the synthetic method or the inspection method, then we are able to can do that. So with this inspection method, remember, you need to just multiply the squares. Then you only look at the square, the value with the square. So if I can just end up here in doing this one with the inspection, because I know I just love the inspection method. Just try it again with the inspection method on this one. Inspection, then we're going to have x minus 2 as one factor. How do I get the other factors? So you get x squared. How do I get the plus 20? You get plus minus 10 there to get the other factor. Because minus 2 times minus 10 will give us plus 20, so we're done with it. So this x squared, we need 7x squared. So I'm just going to make space here. So how much do I have here? I have minus 2x squared. I need to add it with something to get negative 7. So I can divide throughout by I can remove the squares. I'll have minus 2 plus my box, it's equals to negative 7. So I'll have a box equals to negative 7 plus 2, it's negative 5. So my box here will be negative 5, and I just put an x. Can you see it's the same thing as that one? Then from there I can just carry on by doing my formula. So the inspection method is also working very well. If you feel comfortable with it, no problem. If you do not have an x squared here, then it means that this part here will be a 0, isn't it? You'll have a 0 here. So in other words, you're working like that. So I'm going to ask you to please make sure that you do this work, you practice this, you understand it, so that we don't waste time when we do the graphs. When we do the graphs, we don't want to come back here and say, but we have shown you how to do this. Please go and practice this, and I'm hopeful that you'll get it right. And thank you so much for tuning in. Thank you.